first topic is limits. Okay, so there are three types of limits. Plug it in. Factor and plug in. Limits to infinity. Okay, so there's the type where we just plug it in. The second type where we have to factor first and then we plug it in. And then we have limits to infinity, and those are broken up into three different types. So group one, we got Bobo. If it's bigger on the bottom, it's equal to 0. Then we got, I call it Bosco. Both of them the same as the value of the coefficients. I call it Bunny. Call it what you want to remember. Okay, but bigger on top, there is no end. So if there's no end, it is positive or negative infinity. Okay, so let me say that you only do these if it is going to infinity. If it is going to a point, then we either plug it in or we factor and plug it in. All right, so let's look at a couple of these quickly. The limit as it goes to infinity, I've got 3x over negative 7x. They have the same degree, so it's the value of the coefficients. So this one is negative 3/7. The next one, we've got a degree of 4 in the denominator, degree of 3 in the numerator. So this is bigger on the bottom. It's going to 0. This one is bigger on the top, so it is either going to positive infinity or negative infinity. And so the way that you check is to check the sign. So I'm plugging in negative numbers, but the negative numbers are positive in the numerator since it's x to the 4th, and they're negative in the denominator. Positive divided by a negative means this is going to negative infinity. Because it's going to negative infinity.
I have a question.
Yes.
I thought like this Boston, that was like synthetic division. Right?
Wait, coach, if that x to the 3 was x to the 4, then that would be a positive infinity. Since
No, if that were, if it were x to the 4th, then it would be 1 because it's 1 over 1.
oh,
Okay,
x to the 6,
right.
for example.
Instead, if it's like x to the 2nd,
Yeah.
then yes, it would be positive.
Okay.
Okay, so those are limits to infinity. These are limits going to a point. So if it's going to a point, then we plug it in. So I plug in 0 and I get 4. And I plug in 5 and I get 9. And this one, if I plug it in, you're going to get 0 in the denominator, which means it's undefined, but you can factor it. X plus 2, x minus 2. And then the x minus 2's cancel there, meaning that there is a or a removable discontinuity, right? Is the technical term. All right, so if I plug in the 2, I've got 4 over 2, so the value of this is 2. All right, and this one, as it gets closer to negative 2, if I plug in negative 2, the denominator is undefined, meaning that there's an asymptote at negative 2. And there is an asymptote because the numerator will not factor. So if there's an asymptote there, then the limit does not exist. If I plug in negative 2, my denominator is undefined. The numerator will not factor. So since it will not factor, there has to be an asymptote at negative 2. And if there's an asymptote, it cannot converge to a point. Therefore, the limit does not exist.
It's a vertical asymptote.
It's a vertical asymptote.
So I was right. Was the bonus on the test?
We'll get to that, okay? You were not right. But the next one, we have the graph. It's the limit as x goes to 0 of sine of x over x. And so if you look at the graph, as we get closer and closer, if you have a graph and you're evaluating the limit, you look at the value that it approaches from the left-hand side and the value that it approaches from the right-hand side. And that is 1 on the left-hand side and 1 on the right-hand side. Therefore, the value of this is 1.
Wait, say that one more time.
I have the graph, and I'm looking, as I get closer and closer to 0, the value on the left-hand side is 1. And on the right-hand side, it is also approaching 1 as I get closer and closer to 0. Since it's approaching the same value, the value of the limit is 1.
So for number 3, there's a hole at -2, or would be +2?
There's a hole at +2.
Oh, see, there's like filter signs. Okay.
And then we have L'Hopital's rule. Okay, so L'Hopital's rule
Yeah.
says if the limit as x goes to a and you have a function over another function, f of x over g of x, and it ends up with an indeterminate form like 0 over 0 or infinity over infinity, then I can take the derivative of the function on the top and the derivative of the function on the bottom and then plug in the limit. Okay, so here's the deal with L'Hopital's rule. If it's a multiple choice, then obviously you don't have to do this. Just answer it. If it's a free response question, though, you must show it is an indeterminate form. And say by L'Hopital's rule. So, like I said, if it's multiple choice, then just answer it. If it's a free response question and it involves L'Hopital's rule, show that it's an indeterminate form first, so 0 over 0, for example, and then say by L'Hopital's rule, so that you do not lose points on the free response. So let's look at an example, some that we just did. Okay, so if I plug in 2, I've got 4 minus 4, which is 0, and then I plug in 2 in the denominator, and I also get 0. So this 0 over 0 shows that it's an indeterminate form. And so then I would say by L'Hopital's rule, so I'm going to rewrite the limit as x approaches 2, and then I take the derivative of the top function, which is 2x, and the derivative of the bottom function is 2, and then I plug in 2, and I've got 4 over 2, so the value of this is 2.
So how do you know when to do L'Hopital's or just factor?
Okay, that's a good question. These 3, maybe the middle one, but I probably would not do L'Hopital's rule. Okay, because you can just factor it in and plug it in, right? But I put these on here to show you that L'Hopital's rule works. But we'll do some others where you're going to need to use L'Hopital's rule. Okay, so like on this one, if you don't have the graph, you might need to use L'Hopital's rule. If I plug in 0, I've got sine of 0, which is 0 over 0. So by L'Hopital's rule, I've got the limit as x goes to 0. I'm going to take the derivative of sine of x, which is cosine of x. Derivative of x is 1. Now I'll plug in 0. Cosine of 0 is 1. I have 1 over 1, and I got the same answer that I got with the graph. So like on number 5, Joe, I would never solve this by L'Hopital's rule because you can look at it. It's going to infinity. You can see the degrees are the same, so the value of this is 3 over 2. However, L'Hopital's rule applies because we get infinity over infinity. And so the limit as x approaches infinity, I'm going to take the derivative of the top and the derivative of the bottom. So I have 6x over 4x, and my x's cancel. And I'm left with 6 over 4 or 3 over 2.
So L'Hopital's doing like the next this formula, right?
Yes. Derivative of the top, derivative of the bottom.
Can it be used like as an alternative?
Well-
Well, just factoring and doing all that stuff.
Okay, so listen. Shh. Next question. I'm gonna solve this first by L'Hopital rule, and then show you another one. Blast from the past. We have the limit as x goes to pi. So if I plug in pi, I've got sine of 2 pi minus sine of 2 pi, which is 0, and also 0 on the bottom. So by L'Hopital's rule, we've got the limit as x goes to pi, and I'm going to take the derivative of the numerator. The derivative of sine of 2x is 2 cosine of 2x.
Let's go, that's an Arctic one over there.
Oh, yeah, that's.
Yeah.
Okay, you got it. You got it. You did.
People on the video are not going to care, so let's keep the side comments to a minimum, okay? Derivative of x is 1. So now I plug in pi and the cosine of 2 pi. Mr. Arte, what's the cosine of 2 pi?
It's 1.
It is 1, so I've got 2 times 1 over 1, so the value of this is 2. However, there is another way to solve this, because I said this was a blast from the past. Because we were doing this before we even knew about L'Hopital's rule. I took this example from the 3.1 notes. Do you remember? Of course you don't, because you probably missed it on the test. Okay. This is the alternate definition of derivative. Okay. So the other way to solve this, and we will look at this in just a second also, but the other way to solve this right here, it means take the derivative of the function. And my function is right here. Sine of 2x. So what is f prime? 2 cosine of 2x. And what point is it evaluated at? Pi. So I plug in pi and I get the same thing that I just did. Okay. So you can either do this by L'Hopital's rule or the definition of derivative, which we will look at in just a second. But let's look at a couple of examples. The limit as x goes to 0 of e to the 3x minus 1 over x. So I plug in 0, I get e to the 0 minus 1 over 0. E to the 0 is 1. So I end up with an indeterminate form, 0 over 0. So L'Hopital's rule applies. I've got the limit as x goes to 0. I'm going to take the derivative of the numerator, which is 3e to the 3x. Derivative of the denominator is 1. I plug in 0 for x and I end up with 3e to the 0 over 1. And e to the 0 is 1. So the value of this is 3. Okay. The next one, I want you, before, I will work it using L'Hopital's rule, but I want you to think about it first. Okay? Because this is the limit as x goes to infinity. So I could do one of the Bogle Bosco, but it's, if you think about this, little outside the box, which is increasing faster, the natural log of x or 2 times the square root of x?
Natural log, baby.
Well, if you don't see that immediately, I would suggest using L'Hopital's rule. Because if I plug in values, I'm going to get infinity over infinity, which is an indeterminate form. So I can use L'Hopital's rule. So I've got the limit as x goes to infinity. The derivative of the natural log of x is 1 over x. And this is 2x to the 1/2. So the derivative is 1x to the negative 1/2. And what can I do with the negative exponent? It goes to the top and it becomes positive. So this is x to the 1/2 over x. Correct? Okay. Well, now I'm going to do Bobo Bosco, which has the higher degree, x to the 1/2 or x to the first? X to the first is higher, so this is Bobo. So the value of that is 0.
What?
So the answer to my original question, yes, the square root, 2 times the square root of x is increasing faster than the natural log.
Yeah, but could you not just do bot and or whatever that's called? At the beginning?
No,
But there's like the bottom less than the top, right? Because it's.
no, it's different because of the natural log of x. That's not a polynomial with a degree. All right, here we go. Let's look at C. The limit. Hold on, man. Buckle your seatbelts. Because here we go. The limit is x goes to pi over 2 of secant of x over 1 plus tangent of x. So if I plug in pi over 2, we get secant of pi over 2, which is
1 over cosine.
it is 1 over cosine.
Oh,
Therefore, it is undefined.
Why?
Okay. Because secant of x is 1 over cosine of x, and then cosine of x, cosine of pi over 2 is 0. Therefore, you have 1 over 0. Therefore, this is undefined. So let me say something. Here in a little bit, probably next week, I will give you a cheat sheet. It's 1 page, front and back, and the name of it is Stuff You Must Know for the AP exam. Trig values in the first quadrant are on them. Okay, you got to know your trig values. So this is undefined. What's the tangent of pi over 2? Let me tell you what one of my students in second period said. I'm guessing it's undefined because then we could use L'Hopital's rule in the L'Hopital rule section. And I'm like, way to answer the question without knowing the answer, right? Yes, it's also undefined. Tangent y over x. It's undefined. Trust me. Okay, so I've got the limit as x goes to pi over 2. I'm going to use L'Hopital's rule. Hey, here's another thing that's on the cheat sheet. Trig derivatives. What's the derivative of secant of x?
Let me do it, boys. Secant tan x.
Secant of x, tangent of x. And the derivative of tangent? Secant squared. Well, can I simplify this?
Yeah, you can cross out stuff.
I can, like that. So this is the limit as x goes to pi over 2 of tangent of x over secant of x. So hold on here. If I plug in pi over 2, I'm going to get undefined over undefined again. So I'm thinking through this process. I could do L'Hopital's rule again, but if I did that, I would just get secant of x tangent of x, excuse me, secant squared of x over secant of x tangent of x, and it would just be undefined again. So,
I think your answer is going to be
well, I mean, one person in my previous class suggested that I just like, hey, let's just give up and cut our losses. But my point was,
I look, you have a suggestion too.
hold on, let me finish. I'm like, if we're in the kayak paddling across the river, we don't just jump out of the kayak in the middle of the river. The current's just gonna sweep us away, right? I mean, the time to abandon ship would be before you actually jump into the river, right? So, let me think, hold on, wait. I've got it.
I got it.
Trig identities.
I was selling this for that. Cosine.
I'm pretty sure
over
Jacob
sine.
was going to say, hey, I had pre-cal during the pandemic and I didn't learn anything.
Oh, I did not. I so did not.
All right, so look. Sine of x over cosine of x is tangent. Secant of x is 1 over cosine of x.
I literally, but you have to flip it over because.
Flip it, and what happens to the cosines?
I don't know.
So it's just.
They
sine.
do.
Oh my.
I legit swear to you, I was thinking of that.
Then we have the limits. Then we have the limit as x goes to pi over 2. I plug it in, the sine of pi over 2.
Come on, finish it, Jacob. Finish it, Jacob.
Sine of pi over 2. 1.
And d. All right, let me show you one more example. Because sometimes we need to repeat ourselves.
Are we done?
Sometimes it's helpful to repeat ourselves, especially involving L'Hopital's rule. So look, I have the limit as x goes to negative infinity. Okay, again, you could work this without using L'Hopital's rule, but L'Hopital's rule might help you see it. Okay, so if I plug in values, it's going to be infinity over infinity. It's going to be an indeterminate form. So I'm going to use L'Hopital's rule. Derivative will give me 2x over negative e to the negative x. And again, you could look at this and think about it intuitively, but that might not be exactly clear. Okay, but if I plug in negative infinity, I'm going to get another indeterminate form. So my point here is I could do L'Hopital's rule again. And if I do that, I'm going to get derivative of 2x, which is 2 over positive e to the negative x. And now, if I think about this, I have a constant 2 over e raised to a variable. And so which one is increasing faster? Obviously the denominator. Therefore, it's getting much bigger in the denominator. Therefore, this is Bobo. Therefore, the value of that is 0.
Why did you take the derivative bit again?
Of the bottom?
Yeah.
Okay, so when we take the derivative of e raised to the something, we bring that down, so e to the negative x, and then we multiply it by the derivative of the exponent, which in this case is negative 1. So it would make that negative. If we did that again, it's going to make that positive.
But why did we take the derivative of it again?
Okay, got it. Because you may not be able to tell intuitively which one is increasing faster, 2 to the x or negative e to the negative x. So my point is, you could do L'Hopital's rule again, because if I plug these values in, you're going to get an indeterminate form again, infinity over infinity. And so I did L'Hopital's rule twice. That makes sense? All right, I tell you what, I'm going to skip the next 2 for the sake of time, because we really need to talk about some other topics. Continuous functions, as it were. So here we go. I bet, no,
They're pumping.
I used to teach stats, right? So I don't bet.
What probability?
However, I'm going to say no on this one. Do we remember the continuity test? Hold on.
Ooh, I might even know, could you not?
That's too much.
I mean, Joe with the RT yesterday and Zach knowing the answer. I mean, the end is near, right? A function is continuous at a point if and only if all the following are true. Zach, what's the first thing?
No,
You can't just set me up like that and then abandon ship.
Then you gave me a second.
There you go.
I'm understanding.
I don't have a second. I know, Mr. Jones, I'll cover, I'll phone a friend.
And it's
All right.
differentiable.
Okay, no, it's whenever the positive one goes and the negative one equals each other. It's when they
Hold on,
equal each
hold on,
other.
hold on, hold on,
Oh, yeah.
hold on. Let me, how about I do?
But I was right.
The point is it exists.
Yes, it exists.
F of C exists.
Okay, but then.
So the point has to exist. It can be continuous if there's an asymptote at the point or a hole. Okay, so the point has to exist. The second thing is, Eliza, the limit as x approaches C must also exist.
Oh, is the other one both sides?
That's when they both equal each other,
Yeah,
right?
So-
from the left and right.
hold on.
equal the same thing.
That's what I said. But none of that works.
Okay. So at the hole here, the point does not exist. So that would fail part one of the continuity test.
Indeed.
Okay. If I were to put a dot right there and define the function, now the point does exist. So it passes one. The limit also exists because how do I tell if the limit exists? Is it approaching the same point from both sides? So it's approaching the hole from the left-hand side and it's approaching the hole from the right-hand side and it's approaching the same hole. Therefore, the limit does exist. However, it fails. The limit as x approaches C must equal the value. And so this fails the third part of the continuity test, which says that the value of the limit must be the value of the function at the point.
Yeah, I was low-key saying the second part though. You know what I mean?
Okay. And that leads us to differentiability. If a function's left side derivative and right side derivative are not equal, the function is said to be not differentiable at that point. And graphically, you would see a cusp or a corner. Okay, so I've got a little corner here. This is continuous, the point exists and the limit exists, and they're equal to each other. However, this is not differentiable at the top here because the slope on the left-hand side is some positive number, and the slope on the right-hand side is some negative number. Therefore, it is not differentiable.
Yeah.
Okay. However, if it is differentiable, then it must be continuous. So the fact that it has a derivative means that it is continuous. Not the other way around, however, because we just saw this is continuous, but it does not have a derivative. But if it does have a derivative, then it must be continuous. Yes.
So is it the same if that was like parabola, or does it have to be a corner?
We'll look at that in just a second. But a parabola does have a derivative because at the vertex, it would have a horizontal tangent and the slope would be 0. Therefore, the derivative would be 0. Okay. So this says let f be a function with f prime of 3 equal to 7. Which of the following statements is true? F must be continuous at x is equal to 3. F definitely is not continuous at x is equal to 3, or I don't know. Well, the answer to this has to be A, because this right here says at x is equal to 3, there is a derivative, and the value of that derivative is 7. So it does have a derivative, therefore it must be continuous at the same point. So before we answer the next question, let's look at the graph here and let me ask you some questions.
Alright.
Are there points on the graph that are not continuous?
Yeah.
Yes.
Where are they?
X equals 2, 4, 2.
2.
Okay, there's a removable discontinuity at 2. There is a jump discontinuity at 4. Are there points on the graph that are not differentiable?
Yes.
At 3.
At 3. At
Well,
2.
Hold
at
on, let me go through
5.
them. At 2, it is not differentiable because we just said it is not continuous. And if it is not continuous, it does not have a derivative. At 4, it is also not differentiable.
Because it's not
No,
continuous.
because it's not continuous. Also, at 3, the slope on the left-hand side is not equal to the slope on the right-hand side. Therefore, it is not differentiable, but it is continuous. So now let's look at that point. Is it differentiable at this point?
Yes.
The answer is yes, because I can draw one tangent line that has a slope of 0. What about the limits? Is there a limit at 2? Yes, because the limit as it approaches 2 is 2 on the left-hand side and also on the right-hand side.
Yeah.
Is there a limit at 3? Yes,
Yeah.
it's 5. Is there a limit at 4? No,
sir.
because it's approaching 2 different things from each side. So the graph of the function f is shown above. Which of the following statements is false? Okay, the limit as x approaches 2 exists. Yes, we said that that is true. The limit as it approaches 3 exists.
Yes, sir.
Yes. That does not exist because there is a jump discontinuity.
What is it? What's it gonna ask me for whenever it says like if it wants to know like if it's continuous?
It might ask you to, excuse me, to show that it's continuous using the continuity test.
Oh.
So then you would say, does the point exist? Does the limit exist? Using limit notation, and then are those two things equal to each other?
Wasn't this unit 1? I'm going back. I was watching you on my little computer back in the day.
Oh my God.
So
Not like,
if it's
not like
continuous, then
Shh, Hold on,
it is.
let me answer this
How does
question.
it go? If it's continuous, then it is differentiable.
No, other way around. If it is differentiable, then it has to be continuous. For example, this is continuous at this point, right?
Yeah.
But it's not differentiable.
No.
But if it is differentiable, it has to be continuous. All right, so let's look at this question. This is a good question. It says find the values of a and b that make the following functions differentiable. So if it is differentiable, then this is a piecewise function, so both pieces would have to have the same derivative. But what they want you to realize, because if you just look at the derivative, you're still going to be missing variables. It also has to be continuous. And so the way that you check continuity with a piecewise function is you set both pieces equal to each other and plug in the value at where they meet. Okay, so this, I'm going to take ax to the third minus 2 and set it equal to b x minus 2 squared plus 10. And then I'm going to evaluate it at x is equal to 3 because that's where the piecewise function comes together. So if I plug in 3, I get 27a minus 2 equals, let's see, 1b plus 10. So for the sake of simplicity, I might want to solve this for b. So I could say that b is equal to 27a minus 12. And I'm still missing 2 variables. So I'm going to have to check, that was continuity. Now I will check the differentiability, which means I will take the derivative of both sides. So derivative of ax to the third is 3ax squared. And derivative of -2 is 0. And this, let me expand this. This would be b times x squared minus 4x plus 4 plus 10. So I've got b x squared minus 4bx plus 4b plus times 10, expanding that. So I need to take the derivative of that. So the derivative of bx squared is 2bx. The derivative of negative 4bx is negative 4b. And then those are constants, so the derivative is 0.
Why can't you just do the technical?
That's fine. Either way. So now I know what x is. X is 3. So when I plug in 3, I've got 9 times 3. So that gives me 27a equals 6b minus 4b. So 27a equals 2b. Okay, so I could solve this for b and then substitute the value in. Or if you notice, 27a is equal to 2b. So I'm going to put 2b in for 27a because they are equal. And now I can solve for b. So I move the b over and move the 12 over. So b equals 12. Everybody okay with the algebra? And then I plug 12 in. So I've got 27a equals 24. So a equals 24 over 27 or 8 ninths. Oh, we got 17 minutes left.
Oh,
Use a lawyer's calculator.
All right,
Wait, hold on.
almost.
After, okay, what did you do after the 27A equals 2B part? What did you do? I lost it there. Yeah, 2 of them. Wait, how did you get like? Oh, okay, okay. I don't know. Because I was so confused as to where that came from. Where did you get the like? What do you know? Like.
Is that 6B?
Yeah.
6b minus 4b.
How did you get?
I put in 3 for x.
Okay.
X is 3. All right, so pay attention, please, to the next one, because I see this a lot in the multiple choice, and a lot of people miss it, and they really shouldn't. Okay, once you realize what they are asking, they are easy. This means take the derivative. Take the derivative of the function. Okay. So anytime you see the limit as h goes to 0, my function is right here. If you see the limit as x goes to a of f of x minus f of a over x minus a, that means take the derivative and the function is right there. It's in the numerator before the negative sign. Here it's in the numerator after the negative sign. Okay, so look. And like I said, I see these a lot on multiple choice. The limit as h goes to 0. Okay, so I'm thinking derivative of the function. Where is the function? Don't say it's sine of pi because that's not a function. That's the point. That's a point. Okay. What is my function?
so it's an H.
It's sine of x. That is my function. What does this mean? It means take the derivative. So what's the derivative of sine of x? Cosine of x. And then I'm evaluating it at pi. Well, f prime of pi is going to give me the cosine of pi. And of course we know that, right? I know that from like the last test. You know what the cosine of pi is. Has to be -1.
So all that other stuff doesn't matter.
Basically, no. So let me,
What's the point of the zero?
that's part of the definition of the derivative. If you go back and look at the 3.1 notes, you have like a side-by-side comparison with both of those. Okay, so let me do another example.
Coach, I already got sine of x, not sine of pi.
Okay, sine of pi is not a function. It's just a value, right?
Yeah.
So what is the function there? It's this. This is just the function evaluated at pi. So that function is sine of x, and it's being evaluated at pi. So look at this from the last test.
Yo.
What is the function? The function's right there. F of x equals the natural log of x plus 3. What does this mean?
Wait, hold up, so like why? Oh, okay.
What does this mean? This means take the derivative. So what's the derivative of the natural log of x plus 3? It's 1 over x plus 3. At what point is it evaluated at?
2.
2. Therefore, this is 1/5.
So could you do what?
You could do L'Hopital's rule on this. It would work, yes. And that's what I was showing you at the beginning of the notes, where we did a L'Hopital's rule example, but it was also the alternate definition of derivative.
Oh, that's what this is called?
Okay. Almost done. You need to be able to recognize these two things. Okay, they both mean take the derivative of the function, where the function's right there, or the function's right there. And the difference is this is the limit. It's always the limit as h goes to 0 for this one. And this is the limit as x goes to a point here. Okay, so we have a graph here. It says which of the following statements is false. So look at this. The limit as x goes to 0 of f of x minus f of 0 is equal to 0. So if I take 0 and plug it in, I've got f of 0 minus f of 0, which that has to be equal to 0. So that is true. Here, I have the limit as x goes to -1 of f of x minus f of -1 over x plus 1. This is the alternate limit of derivative. Alternate definition of the derivative is what I meant to say. Okay, evaluated at what point? At x is equal to -1, is the derivative 4? The value of the point is 4, but the derivative is the slope of the graph, and the slope of the graph is not 4. It's negative. So that has to be false. And so now look at the other two. The limit as x goes to 2 of f of x minus f of 2 over x minus 2 is equal. Okay, so this is asking what's the derivative at 2? Is it -1? The slope of the graph is -1. Yes. This is saying, what is the derivative at 1? Well, the derivative at 1 is a corner, therefore it is not defined. It is not differentiable at 1, therefore it is undefined. That is also true. So the answer is B. So, using the same graph here, it says, suppose g of x is equal to f of x minus 2 over x minus 3. Find the limit as x approaches 3 of g of x. So I've got the limit as x approaches 3 of f of x minus 2 over x minus 3. Okay, so what is this asking? Take the derivative of what point? At 3. You're like, where did the 2 come from? Well, what's f of 3? It's 2. Well, what's the derivative? Has to be -1. It's the slope of the graph. Okay, one more.
Let's freaking go.
Man, I'm just on fire today. All right, so here we go.
Did anybody get that bonus right?
No.
I mean, not to throw Joe under the bus. He didn't get a true or a Tay, right? It wasn't 14. It wasn't, but I did have one person that got 14 out of 13. Yes, not in this class. There we go.
Mind if you said their name.
I don't think I wouldn't.
I would want you to say it.
You can say.
The function measures the fish population in Blue Lake at time X, where X is measured in years since January 1 of 1950. If F prime of 25 is equal to 500, it means that, okay, so I see this question a lot on the AP exam, and it's really not hard if you just think about what it means to have a derivative. So the derivative is a rate of change. So if you think about this, f of x in this context would be an amount. F prime of x would be rate of change of the amount. Right? So I'm looking for f prime of 25. There are 500 fish in the lake in 1950. No, that has to be wrong. It's an amount. And you're not even looking at 25. It's the original amount. There are 500 more fish in 1975 than there were in 1950. That's wrong also because that's an amount. On the average, no, right? The fish population increased. So the correct answer on January 1, 1975, X is 25 or T is 25 in this case. The fish population was growing at a rate of 500 fish per year. That's the derivative. Has to be D.